We're going to take a look at just a couple examples of long division and synthetic division for polynomials. With long division, we want to include all of the terms, and we're going to focus on just the first term of the binomial, and we're going to look at, again, taking x to the third divided by the x minus 1 term, so just divided by x. And notice that that's going to be x squared. So that's going to be the first factor here. So then we go ahead and multiply x squared through times x minus 1. And then we will subtract. And when we subtract, we end up with 5x. 5x squared. So then go ahead and bring the rest of the polynomial down. And then we focus on just the first term, that negative 5x, and divide that by x, and we'll get negative 5. And then again, we multiply that through. So negative 5 times x minus 1 will give us negative x squared minus plus 5x. Go ahead and subtract each of those, and we'll get negative 8x plus 8. And then again, that's the term we focus on with the first term x. So negative 8x divided by x is negative 8. And go ahead and then multiply that through. And notice here, when we subtract, we will get a remainder of 0. So the answer, when we go ahead and divide by x minus 1, is going to be x squared minus 5x minus 8. And again, notice there's no remainder here, so it's just this quadratic. Again, here, this polynomial, this fourth degree, is going to be divided by a binomial. And again, we're going to start off with all of the terms, and we really just focus on one term at a time, and we go ahead and take a look at that x. So the x plus 2, so we'll go ahead and divide the first term, 4x to the fourth, and just focus on that at the moment, and we'll divide that by just the first term of the binomial x plus 2, so 4x to the fourth divided by x is 4x to the third. Just notice we'll line those up so that all the third degrees are in the same column. So go ahead and multiply that out then with the x plus 2, and notice we'll get 4x to the fourth plus 8x to the third. Then we subtract those two terms, and we end up with 6x to the third. Bring the rest of it down, and now we'll just focus on the first term of this of this polynomial that's left, and again divided by x plus 2, so really just the x's. And if we divide 6x to the third divided by x, we get 6x squared. Again, we multiply out and then subtract. And so once we subtract, we get x squared, and we're going to just focus on the x squared part then. And x squared divided by x is x. And then go ahead and multiply that x by x times 2. And then subtract again. And notice here that we'll get negative x minus 2. And that leaves us with the last part of this, which is x divided by negative x is negative 1. And if we multiply that negative 1, notice again we will end up with a remainder of 0. So when we divide this polynomial by x plus 2, notice that it is a complete root, and it does not have a remainder. So that means it factors completely when we think about long division. So if you're dividing by just a binomial, a simple factor like x minus 3 or x plus 1 or x minus 2, we can do a little bit of a shortcut with the idea of synthetic division. Remember, all we're going to do is that x plus minus 3 term becomes a 3, and then we bring down just the coefficients. And this is really just an operation with the coefficients where we multiply by 3, and then we add, and multiply by 3 and add, multiply by 3 and add. And once we do that, the last term is going to be our remainder. And so again, since when we multiplied and added, the last number was a 0, that's fine. So we have a remainder, and then since this was a 4th degree polynomial and we're dividing it just by a 1st degree, we know it has to be a 3rd degree that's left. And so really what we're going to do is then just bring down the coefficients and go ahead and we get our solution. What is the result after we divide by x minus 3? Since it's a remainder of 0, of course it is a factor as well. Again, synthetic division, nice little shortcut with the coefficients where you can kind of work with the coefficients only. It only works when we're dividing by either an x plus or an x minus factor. And this division problem, we can also use synthetic division because of the x minus 5. And again, you could use long division here as well. But again, synthetic division is really just to work with the coefficients. We're going to add and multiply by 5 this time. And so since we're multiplying by 5, we will end up with, again, at the end, a remainder 0. Since this was a 3rd degree and we divided it by an x term, it's going to be an x squared term, which we would end up then just bringing down the coefficients, and we'd have, again, a quadratic. So x minus 5 is a factor because the remainder is 0, and this is again one of the things we're looking for when we're thinking of zeros or factors. If the remainder is 0, then x minus 5 is actually a factor.